Hello everyone and welcome back to Introduction to Number Theory. In this video we will discuss the notion of the greatest common divisor. So take Euclidean ring and two arbitrary elements of this ring where at least one of them is not zero. Then we have a definition of the greatest common divisor of these two elements. We denote these elements as A and B, and denote the greatest common divisor as either GCD of A and B or simply A and B inside the brackets, just as scalar products, so don't mix them. If two conditions hold. First of all, D, the greatest common divisor, should be indeed a common divisor, which means that both A and B should be divisible by D. And the second condition is that for any common divisor of A and B, we denote it by C here, D should be divisible by C. So the greatest common divisor is divisible by any other common divisor of A and B. Note that from the last condition it follows that norm of D is indeed greater or equal than norm of C. So this is why we call this common divisor the greatest. It is the greatest according to the norm and also according to the divisibility. Now let's consider several examples. For instance, in the ring of integers, take 42 and 78 as A and B, and their greatest common divisor is 6. However, at the same time, their greatest common divisor is -6, because both 6 and -6 satisfy the condition from the definition. Well, 42 and 78 are divisible by both 6 and -6, and also if we take arbitrary common divisor of 42 and 78, well, for instance, they're both even, so 2 is their common divisor, number 2. And both 6 and -6 are divisible by 2. So we see that in the ring of integers, any pair seems to have any pair of integers seems to have two greatest common divisors. Let's consider the set of complex integers. We see a more interesting picture there. If we take, well, this pair of complex integers, then any of the 4 complex integers on the right-hand side is the common divisor of these two complex integers. 2 plus 3i, minus 3 plus 2i, minus 2 minus 3i, and 3 minus 2i. And you may have noticed what is the connection between these greatest common divisors. They are associated to each other. One can be obtained from another by multiplying by a reversible element of the ring. Well, reversible elements in the ring of integers are 1 and -1. And reversible elements in the ring of complex integers are 1 minus 1, I minus I, where I is the imaginary unit. So it is easy actually to show that, well, if a certain pair A and B has two greatest common divisors, then these two greatest common divisors are associated to each other. And of course, any element associated with the greatest common divisor will also be the greatest common divisor. So please get used to the fact that greatest common divisor is not uniquely defined. However, it doesn't matter actually, because when it comes to divisibility, associated elements act just the same. So there is no difference between associated elements. So this is quite okay, and we will have to live with this.